and you not need it, then vice versa. So, but I'm going to review over a topic called factoring. And the reason I'm going to review over this topic, you'll see shortly into this section, but probably for the most part, this video here is just going to be strictly a review over something that you need to be reminded of, that we're going to use a lot of, not just in this section, but a lot throughout the rest of this course, which is one of the reasons why we stop and do this right here. And so I want to talk to you about something. I want to talk to you about factoring a polynomial. Now, first of all, let me remind you what factoring is. Factoring, when you factor a polynomial, what you're doing is you're looking for what two things or more multiplies together to give you that polynomial. For instance, if I ask you to factor 15 or 24, what I'm looking for is give me some things that multiply together to give you 24, like 4 times 6 and 3 times 8, or 2 times 2 times 2 times 3. Or 3 times 8 a while ago. So multiplying things together to give you 24. So when you factor something, you're looking for what things multiply together to give you that. Now, if you remember about factoring, and I'm not teaching factoring, I'm reviewing over factoring. So I'm going to hit the high spot. So if there's other gaps or deficiencies you have, you may need to go back in and do a little digging on factoring. But I will hit the high spots for you. But remember, when you're factoring a polynomial, not all polynomials factor. Those that won't factor we call prime. For instance, if I ask you to factor the number 13, of course it factors 1 times 13, but it doesn't factor any other way. So not all polynomials are factorable. But whenever we factor a polynomial, we typically factor in algebra, we factor polynomials that contain 2 terms, 3 terms, and 4 terms. Now, I'm not going to go back over all of those because we don't necessarily need those for this course. But I am going to remind you how to factor binomials and how to factor trinomials. But before I do either one of those, let me remind you first this. The first thing you do whenever you're factoring a polynomial, I don't care if it has 2 terms or 3 terms in it, we always look for a GCF. So let me just remind you what that is. Suppose I wanted to factor this problem right here. 15x squared plus 40x to the 5th minus 10x to the 4th. This is a trinomial. So the first thing I would ask myself is, what is the biggest thing that goes into all 3 of these? Now remember, your GCF can be a number or a letter raised to a power, or it can be numbers and letters as well. If you look at these 3 terms right here, you can clearly see that 5 divides evenly into all 3 of those numbers. But if you'll notice, you've got an x2, an x5, and an x4. So you can divide out an x2 into all 3 of those. If you remember, yes, it's just simply the lowest power of those. But it has to be present in all 3 of the terms. So 5 into 15 would be 3. x2 into x2 cancels. Remember, you subtract exponents when you're dividing. Plus 5 into 40 is 8. x2 into x5 leaves x3. And then 5 into 10 is 2. x2 into x4 is x squared. Notice 2 things here. Number 1, you know that you took out the greatest amount if there's nothing else that divides into the terms that's left. And there's not. Next thing, notice that if you distribute this, it will take you right back to where you started. So I found 2 things, this times this, that multiplies together to give you that. So I have factored that polynomial. Now, I said a while ago, there's 2 kinds of factorings you need to be reminded of. Number 1 is binomials. Now, there's two things that you have to look at when you're factoring a binomial. One is a GCF, and two, if you remember, is what's called the difference of two perfect squares. Now, there's a third one also that we look at in intermediate that we're not going to look at in here. So when you look at a binomial, you ask yourself two questions. Does it have a GCF? If it does, bring that out. And the second question is you ask yourself, is it the difference of two perfect squares? Let me show you an example of the difference of two perfect squares. This one right here, x squared minus 64. There's no GCF. This is the difference. That means it's got to be subtract. Must be subtract. Of 2 means it's got to be a binomial. And then they have to be perfect squares. Now, what is a perfect square? A perfect square is something that if you break it up, one way you can break it up is something times itself. Well, x squared is a perfect square, x and x. 64 is a perfect square, 8 and 8. And then one's a plus and one's a minus. Because a positive 8 times a negative 8 is a negative 64. Yes, they will always be opposite in signs. No, it does not matter which one you put first. Let me show you another difference of two perfect squares. 4x squared minus 49. The difference of 2, perfect square, 2x, 2x, perfect square, 7, 7. So this is 2x plus 7, 2x minus 7. Now, let's do another one. Now, this one is a little unique because first, it is the difference of two perfect squares. However, it also has a GCF. Now, remember in mathematics, order matters, the order in which you do things. So, if this problem has a GCF and difference of two perfect squares, you have to do these in the right order. So, we're going to always do the GCF first, if it has one. So, I'm going to take out a 9. 9 into 9x squared is x squared. 9 into 81 is 9. However, if you'll notice, this binomial right here, it is still the difference of two perfect square, x and x. 9 is a perfect square, 3 and 3, and one's a plus and one's a minus. But when you factor that, this 9 is just as much of the factoring process as the x plus 3 and x minus 3. So just because a problem has a GCF doesn't mean that it won't go on down and factor again. Now, x squared plus 16. X squared plus 16, is there a GCF? No. Is this the difference of two perfect squares? No. It's the sum of two perfect squares, but not the difference. So if it doesn't have a GCF and it's not the difference of two perfect squares, we call it prime. Another word we use in algebra is called non-factorable. Now, don't write this down. But if I had a penny for every time I've seen algebra students factor that way. X plus 4, x plus 4. If you FOIL this out, you will not get x squared plus 16. If you FOIL it out properly, you will get x squared plus 8x plus 16. You get a middle term. That's why it has to be the difference of two perfect squares. So you say, all right, so every time it's a plus, it's prime with a binomial. No, not if it has a GCF. For instance, 2x squared plus 50. That's not the difference of two perfect squares. However, it does have a GCF of 2. So I can take a 2 out. Now, not an x, because there's not an x in both of these. 2 into 2x squared is x squared. 2 into 50 is 25. Now, this won't break down any further because of the plus. If that had been a minus, then yes, it would have. Okay, now, that's GCF, and that's factoring binomials. Now, the biggest group that I want to talk to you about is factoring trinomials. Now, first of all, a trinomial is something that has three terms in it. But whenever we talk about trinomials, for those of you that, if you had me for intermediate algebra, I break up trinomials into two types. What I call the easy case, and then what I call the harder case. Let me give you a visual of each one. Now, all the trinomials that we're going to be factoring will have this pattern about them. This will be a x squared, a x, and a number. A x squared, a x, and a number. So I'm not talking about just any old trinomial. I'm talking about a trinomial that looks like these. So if this is an m squared, this will be an m. If this is a p squared, this will be a p. So trinomials where you got a letter squared, same letter in the middle, and then a constant on the end. The difference between the easy case and the harder case, the way you recognize it, is simply this. The easy case will always have a 1 in front of the squared term. The harder case will not have a GCF, but it'll have a number in front of that squared term. And this problem right here factors very different than this one right here does. Now let's do the easy ones first, because they're the easiest to go over. So let's do this one. X squared plus 8x plus 12. Now again, I'm not teaching you this. I'm reviewing over. All right, this is the easy case. The x squared always breaks up x times x. That's why we call this the easy case. If this is a plus, this means the signs down here are the same. If this is a minus, the signs down here are different. Now, if this is a plus, the signs are the same. This tells you what they're going to be. So this says the signs are the same, both plus. This is the way I teach it in my intermediate class. I'll tell them, okay, I need two numbers that multiply to fill in the last two spots, two numbers that multiply to give you 12, that add to give you 8. Multiply 12, add 8. Of course, that's 6 and 2. Doesn't matter which one you put where, because they're both plus. Now, is there any way I could check this? Certainly. If you FOIL this out, it'll take you right back to where you started. All right, let's do 4, 5, or 6 of these, because these are really important. Trinomial, there's no GCF. It's the easy case, x squared, x and x. This tells me signs are the same. If that's a plus, the signs are always the same. This tells you what they're going to be if they're the same. So signs are the same, both negative. I need two numbers. If you multiply, you get 10. If you add, you get 7. 5 and 2 or 2 and 5. And if you point to it like that, you won't ever go wrong. Multiply 10, add 7. All right, let's do another one. X squared plus 3x minus 28. This is a trinomial. There's no GCF. This tells me the signs are different. So this is an x and an x. One's a plus and one's a minus. Now, what does this sign tell me then? If this sign tells me the signs are different, this tells me that the biggest number is going to be behind the positive. So my bigger number is going to go right there. Signs are different. Largest is positive. All right, so how do you fill in the last two spots? You ask yourself two questions. Two numbers that multiply to give you 28, but subtract to give you a plus 3. Multiply 28, subtract 3. 7 and 4, but you need the 7 positive and the 4 negative to get a plus 3 out of that. And if you FOIL that out, it will take you right back to where you started. Okay? Let's do 3 more of the easy case. X squared minus x minus 30. No GCF. This is the easy case. X squared breaks up x times x. Signs are different. Largest is negative. So the largest number is going to go right there. I need two numbers. When you multiply them, you get 30. If you subtract the two numbers, you get a negative 1. Multiply 30, subtract 1. 6 times 5. 6 times 5 is 30. If you subtract 6 and 5, you get 1. But you need a negative 1 out of that. So the 6 has to be with the negative, and the 5 has to be with the positive. Now, if you put the minus in the first parentheses, that's okay. As long as the 6 is behind the minus, and as long as the 5 is behind the plus. All right, let's do two more easy ones. X squared minus 8x minus 15. This one is going to show you the importance of making sure you know the rules about your signs. Okay, trinomial, no GCF. Easy case because of the 1. X squared breaks up x and x. Signs are different. Biggest is negative. Biggest number is going to go there. I need two numbers. When you multiply them, you get 15. But if you subtract them, you get 8. If you're not real careful, you'll say 5 and 3. Multiply 15, subtract 8. 5 and 3 doesn't subtract to give you 8. That adds to give you 8. There are no two factors of 15 that subtract to give you 8. This one is one that is prime, or non-factorable. Now, you swap that sign to a plus, that means the signs are the same, both negative. So both of these would be minus. Now you're looking for two numbers that multiply to give you 15 that will add in that case. So that's why you have to understand the rules about the signs. Trust me when I tell you, you can put that 3 and 5 in here all day long, and I promise you, if you FOIL it out, you will not get that right there. All right, let's do one more of this type. Now you said, wait a minute, this is a trinomial, but this is not the easy case because of the 2. You are correct, but remember, what is the first thing we're supposed to look for in factoring? A GCF. Does this have a GCF? Yes, it does. It has a GCF of 2. So if I take a 2 out, I'm left with x squared minus 4x plus 3. But remember, when we factor, we want to completely factor it. So if this factors again, I want to do that. Well, will it? I have no clue. If it doesn't factor again, I will circle this right here. If it does factor again, I will factor it again. Well, let's see if it will. X squared breaks up x times x. Signs are the same, both negative. Two numbers, when you multiply, you get 3. But if you add those same two numbers, you get 4. 3 and 1. That's 3 times 1 is 3. 3 plus 1 is 4. And then bring the 2 down, because it's just as much of the answer. Okay? Five x squared minus 3x minus 2. Okay, this particular problem, there's no GCF. So that's out. But it's also not the easy case because of that 5. And I told you, when you're factoring a trinomial, if this first term is not a 1, you can't use the same thought process. So in this problem right here, you can't say, I need two factors of 2 that subtract. That won't work anymore because this 5 affects the FOIL process. So how do we factor a trinomial that is not the easy case? In other words, when there's no GCF and that number in front is not a 1. How do we factor those? I will show you that, how to factor trinomials. The harder case in the next video.